So the next one is, I don't remember what I was going to do. 44. Let me do 54 first. Actually, we can do 44. So 44 says 2 points, A and B, are on the shoreline of Lake George. Ooh. A surveyor is located at a third point C. The distance from A to C is 180 meters. The distance from B to C is 120. Measure of angle C is 56.3. To the nearest tenth, what is the distance at A to B? OK. So let's draw a little graph here, or a picture of what exactly they're saying. So we say we've got Lake George. Does everybody remember what Lake George looks like? Right? Of course. Yeah, everybody knows. So it says 2 points of Lake George are on the shoreline of Lake George. So we'll just call this A, and we'll call this B. All right. A surveyor is located at a third point, C. So we'll call C here. And we got a nice little surveyor. Now, the distance from A to C is 180 meters. Then it says the distance from B to C is 120 meters. Measure of angle C is 56.3 degrees. And they want us to ask, to the nearest tenth, what is the distance from A to B? All right? So when using this, what we're going to have to do is we need to look at what formulas or what do we have that we can apply to use this. So there's a couple things. Right now, we don't know if it's a right triangle, right? There's nothing showing that it's a right triangle or that we have a right angle of any sort. So we can't apply the Pythagorean theorem. And plus, we don't even know, we only know, all right, so we don't know it's a right angle, so we can't apply Pythagorean theorem. We also don't know it's a right triangle, so we can't apply any trigonometric functions, right? We can't say the sine of 56 degrees over x and equal all that stuff, because we have to have a right triangle. We cannot prove or know that it's a right triangle at this point. So then we looked at, what do we do? So right now we have what we call, we don't know, it's just an oblique triangle. So we talked about there's two different laws of sine, the laws that we use. We use the law of sine and also the law of cosines, right? So the law of sines, we had to have an angle and its opposite side, right? But when we notice to do the law of sines, we have the angle, we don't know the opposite side, but we have to have at least another pair, right? And we don't have any pairs that we can write a ratio for. So therefore, we have to now use the law of cosines. And if you guys remember the law of cosines, I'll try to see if I can remember it. So we need to be able to figure out little c. So we'll call this little c. And we'll make sure this is big C. So this is big B, little b, big A, little a. So law of cosines, as I remember, is going to be c squared equals a squared plus b squared minus 2 times a times b times cosine of big C. If anybody wants to check on that one for me, I'm pretty sure I'm correct, but I just want to make sure. So now we don't know what c squared is. That's what we're going to try to figure out. A squared is 120, and I will need a calculator here in a second, plus 180 squared minus 2 times 120 times 180 times the cosine of 56.3 degrees. Can I use your calculator? Thank you. So let's go ahead and now write out what we have. So we have c squared equals, so 120 squared, 180 squared, and then we have 2 times 180 times 120 times the cosine of 56.3. And we've got to make sure we're in degree mode, which we are. So that's going to be minus 2,396.9 0.28. So then I'll do 1400 plus 32,400 minus 2,309.69.28. So there it gives me c squared equals 2,208. And then I'll take the square root of second answer. And I get c equals 151.10. Now, let's go and look, and that's going to be meters, obviously. Let's look at the context of this problem. Does that look like that would be a reasonable length for our shoreline from A to B? Yes, right? So we just want to make sure that we completed everything correctly. But yeah, that looks like a reasonable answer, OK? So there you go. I'll keep this. OK, so last one was